Hey, welcome to Web3 Weekly with your host, Blockstar Technology.
Let's go.
All right. Hi, everyone. Hi for all the social nations. How many nations have you got, Charlie? Now?
Quite a few.
About
Quite
seven?
A few. Nathan,
Seven? Six,
what's
seven?
our total?
Oh my God! Like
Plus
seven.
Plus seven.
So, hi to everyone. Thank you for joining us. And this is episode 46. We're going to talk a little bit technical. So, we're going to talk about upgradable contracts. And today we are joined by in-house, like resident smart contract expert, Dr. Mohammed.
Thank you, Cozy. Thanks for having
All
me.
right. Cool. Nice to meet you. So Mohammed, let's get going. So I have today I've been joined by Charlie as well on the side. Before I say,
nice to have you. Nice to have you on, mate. Nice to have you on.
So I think Nathan, can you make it a little bit louder? I think it's hard to. Mohammed, can you hear us now?
Yep. Very well.
Oh, that's better. Yeah, that's all. Sounds good. All right, cool. All right, let's get going. So, Mohammed, so we're going to talk about these upgradable contracts, right? And let's start with what are they? What is upgradable contract? It's a smart contract. It's not a smart contract. What is it?
Are smart contracts now all immutable and can't be changed?
Yeah, exactly. Are they all immutable and can't be changed? Okay, let's start with one place, which is what? What are upgradable contracts?
Yeah. That's a good starting point. But before going through upgradable contracts, let's a little bit talk about upgradability itself, whether we need it for the smart contracts, because as Charlie mentioned, everyone knows that smart contracts are getting popular because they are executing on a blockchain, and blockchain is popular because it's one of the reasons is that it's immutable. So it's one of the tenets that we all are relying on, that it is an immutable ledger, no one can change it, and then let's go there and write some codes and automatically execute it. Then, but the new blockchains, I mean the Ethereum blockchains, not the mother blockchain, the Ethereum blockchains and state blockchains, let's say, they're all having the state variables in the smart contracts. So we know that the logic is immutable, but there's still variables that you can change. And based on these variables, we may have different functionalities. Let's say, for example, if there's a reward in a smart contract, and then you are having a setter or getter, let's say setter function, which sets this reward amount, you can change this reward. The owner of the contract or anyone else, actually, it depends on the strategy. But yeah, so they're still having some features of upgradability in the smart contract itself. But yeah, when we are saying they're immutable, they're because the logic of the smart contracts is immutable. Even upgradable smart contracts or upgradable, let's say, architecture is also immutable. So we can't say they are changing. There's no change. No one is going to the blockchain and change the ledger. No one is able to do.
Okay, so we spoke about when you say the upgradable contracts, the contract is different from the blockchain, right?
Yeah.
So when you talk about the smart, upgradable contracts, you're talking about on EVM, on Ethereum, right?
Yeah.
Cool.
Yeah.
So was this like available natively, or is it something that was available recently, or how did that come around?
Actually, this upgradability is kind of a technique that, because natively we are having some delegate calls in the smart contracts, then some genius guys invented these ways of having proxy pattern and everything that we want to discuss today. But Yes, so I can say that still they are immutable. Every smart contract, even upgradable smart contracts on Ethereum, are immutable.
Hmm.
But what are the some of the motives that push people to this direction? That let's have upgradable contracts. Let's talk about these things first. First of all, is that we all know that the developers and everyone in this space in the IT sector, they know that we are always having post deployment vulnerabilities, no matter how how your expert developers design and deploy these software, any type of software. We know that
Yes,
it
bug.
is
Yeah.
very likely to have bugs. So this is first of all that,
Hmm.
again, in this space also we definitely encounter these bugs. And the other issue was like, because like a distributed or autonomous organization or DAO or any other dApps, they're evolving during the time. So they're starting from a point, maybe a very simple point, and then they get
Yeah.
evolved during the time with more complex interactions, with more rules, with more different roles and different hierarchies, all of these things. And if we want to be a dynamic community, definitely we should embrace these changes and somehow introduce these changes into the smart contract, into the logic of our distributed application.
Okay. So when we talk about the why did we come up, or why did the smart people come up with the upgradable contract? What is the need for it? Is it because you can only have a certain size, like in kilobytes? Is it because you can only certain number of functions? Is it because you save gas? Or what are the top, I don't know how many, are the top three or top five reasons why people
Yeah.
introduced upgradable contracts?
Yeah. So as I mentioned before, there is some motives from the need for upgrading the logic of the smart contract, and
Yeah.
also people were having the problem of the maximum size of smart contract, 24.5 kilobytes of bytecode. So any smart contract that should sit on a blockchain is like it should be encoded by bytecodes. So there are
Got it.
some bytecodes that define that
Hmm.
all of these logics, what are these functions, how they should sort as state variable, how we can access them, change them. All of these logics would be in a form of a bytecode that identifies, that shows how this smart contract would be functioning. And there is a limit of 24.5 kilobytes, which is really, really, restricting when it comes to big applications. So it was another motive that pushed people to this direction of, okay, if we want to have multiple or different, logics, then we need to upgrade them because we cannot introduce them at the first time
Hmm.
developing one smart contract into the blockchain.
Yeah. All right. So why, that we know smart contracts can call other smart contracts, right? In an ecosystem that's available, that option is available. Why would you create these upgradable contracts when you can already can call, other smart contracts from a single smart contract, right?
Yeah. So actually, the point is that when you're talking about normal calls between smart
Mm-hmm.
contracts, it means that when a smart contract, so a smart contract can call a function from other contract,
Yeah.
but the caller would be this smart contract, and all the information, the message sender, whoever calls this function, is the other smart contract, not the people using this smart contract. So this is a normal call.
Yeah.
They are making, for example, to do some calculation, to do some functions that they need, but it is not upgrading. It's not going to be upgraded. So if the day one, uh, contract A calls contract B for
Mm.
function, let's say one, always it's going to be like this. So there's no change or selection or kind of upgradability, because these are just calling static calls, let's say,
Yeah.
which is intrinsically defined by this uh, the logic of the smart contracts. But as I mentioned, some pros of these upgradability, there are always cons, and still there are some people in the community that they do not agree with the idea of upgradability, and there are some reasons for this,
Yeah.
for this
Yeah.
argument. Because, yeah, you
Yeah,
go
I mean,
on.
like from your side, Charlie, you've been like sitting here very quietly, and now that you got so many questions, like in your
Yeah, it's a hard one.
isn't it? Because you're a DeFi guy, right? You just want everything transparent and everything else, and
Lock it in.
lock it in, lock that
Teddy.
in, baby. Yeah,
Yeah.
exactly.
And upgradable, it does pose a risk, but it does have advantages at the
Yeah.
same time.
Hmm.
So
I guess
my understanding of the diamond contracts is you've got your front facing contract, which is like client based that I would interact with, and then you've got the proxy contract, and you can never change the client side contract. You can only update the proxies. So with that being in the client side, you can only keep those same functions, Mohammed, and then adjust how they work in the back end, or you can add in new functions. How does that work exactly?
Yep. Yeah, actually, yes, we will go through all of these things today. So we are having a bunch of information to talk about. But before that one, let me a little bit talk about the negative sides or the cons that, or let's say, somehow vulnerabilities. So, first of all, is that in a DApp or in a DAO or any kind of a Web3 application, when you're having the upgradability feature, it means that you should have some extent of trust to the developers and to the team. So the whole target of decentralization was like, we didn't want trusted systems.
yeah.
We want interactions with trustless parties around the world. But here, because we are adding the upgradability feature, we should know that what exactly would be upgraded, who could upgrade it, when can be upgraded. So these things should be clarified, and uh, because it's very important, because it may end up in a very centralized
So true.
dictatorship in Web3. If you, for example, lock the some tokens, or I don't know, lock the minting process, or whatever,
Hmm.
anything could be changed in the logic contract because it's upgradable. And also, it is highly challenging and a complex task. It's not a straightforward kind of development task that, let's say, even mid-level developers could do it in this space, because it needs a very, it's a very complicated task, because you're dealing with memories, you're dealing with different function selectors, and then if there's any problem there, then the whole system would be ruined. It would be a catastrophic moment for everyone.
Yeah.
And one more thing is that in traditional, let's say, normal smart contracts, if you're having a problem, let's say, in one function, that's only one functionality that could be faulty. Okay, it may have side effects on other functions, it may not. So you may have a situation that one function is faulty, but still the rest of the functions are working perfectly
Yeah.
fine and they can survive. But in an upgradable contract, if some part, for any
Hmm.
reasons, faulty and could not properly function, then people can get into it, and there are lots of security holes there. And then changing the logic, and then, oh man, I cannot even imagine it what would happen, because attacker comes in and then change the logics and then own the tokens, and everything could be could
But
be
can they
ruined.
change it though? But can they change it, because they should not have access to change the contract, right? Unless they change the values. But
They cannot change the values because state variables are there
Yeah.
on the contract, but definitely they would change the logic from now on. So from now on, if let's say 1 million token are minted from now on, only me as an attacker, I'm minting the tokens, and I'm the owner of the whole of these things because I do have the control over minting process and over rewarding process, everything actually.
Yeah. So
So
are you saying, okay, so are you saying that if you are a hacker that who deployed this contract, that you can um, change the contract because it might look right, but then down the line you could change it? Are you saying that, or are you saying that, say for example, we deploy a the one of the upgradable contracts, and then some attacker could come and upgrade it? You're not saying that, are you?
uh so yeah, both of them actually. So if
Okay.
you're working with proper developers, it may end up in a centralization problem because they are the developers themselves and the team themselves are the attackers, real attackers. That this is the trust part that I discussed first, and the second one is that if the upgradable smart contract is not developed with cautious and very well optimized one,
Hmm.
then there are lots of security holes that attackers can use and get into the smart contract. And
Yeah.
when they get into it, they can change the logic of the smart contract, and then everything would be on their control. So this is the part uh, that is
Okay.
really, yeah.
Okay, so I thought that you only the creators could change the smart contract, not a third party.
Well, it depends. A hacker can compromise a wallet, like they
Ah,
did in
yes, and then
Axie
from there they come
Infinity,
and
and they can
yes,
handle it.
yeah.
And then also, what was it? Safe Moon a
Mm-hmm.
few months ago, like maybe 6 months. We lose track
Long
of
time
time
ago,
when you're
man.
having
Oh,
fun.
more than 6 years, about 1 year ago, I think.
Was it 1 year ago?
More than,
Oh,
yeah.
geez, yeah, no,
Like,
six. I'm sure it's
you
six,
see?
8 months where they upgraded their contract, and it allowed their liquidity pool to get siphoned.
Oh, so that was upgradable contract,
They
rather than a new.
upgraded, and then someone realized, because I believe, Mohammed, a question is, I was reading this a while ago. I can't remember the name of it, but
Mm.
Etherscan doesn't yet support upgradable contracts.
No, they do. I
But
think
there's
now
but
you
there's
can see
a
the
they do
proxy.
have it now.
Yeah,
They do have the proxy contracts.
yeah, you can see the
But there was
proxy
another
contract.
one out there, another explorer that did
Hmm.
support that in the early days. So
Okay.
it's been a while since I've been into the upgradable contracts when they
Yeah.
first came out, because I remember Arvagocci was like one of the first people to start using it
Okay.
for their
Yeah.
little NFT
Yeah.
things where you throw your DAI tokens
Hmm.
and you get upgradables on
Okay.
there. And yeah, there was an interview with him about
Yes.
saying the diamond, but each look, if they called it a diamond because each function is like like a cut of a diamond, and
Yeah.
then you piece it all together, and
Okay.
that's
So
what you end up with.
that actually, I was going to ask a question actually. Because earlier you mentioned diamond contract, and we're talking about upgradable contracts. So I'm like, okay, why would you call it a diamond contract? What is the reason? You know, would you be able
uh
to answer that, Mohammed? Or
yeah, but I think there's still are some other patterns we need to talk about, and
oh
then
my
Yeah,
God, look like Mohammed
yeah,
got all that planned out. Not like us. We just like
yeah. No,
we are
you
shooting
got
from the hip, like bam, bam, bam,
yeah.
bam. I was like, no, no, no.
You're gonna learn how to load the gun first, Gozzy.
Oh my God! All right, let's go.
yeah, so I wanted to start with yeeting, to some like, okay, our smart contract number A is this one, then community, everyone, migrate to contract B. This is one way of upgrading.
Yeah.
Okay, everyone, please come to contract B. And then it's also one way of upgrading a contract. And also, as I said, the state variables themselves, into some extent, we can say that they can control the logic.
Yeah.
But yeah, you're right, Charlie. the things that the smart contracts that now we know them as upgradable smart contracts are proxy, are according to the proxy pattern. So what is this proxy pattern? Smart contracts are still immutable, so no one can change them, as I said before. But DApp can be designed to have one or more smart contracts at the backend side. So you're having a one proxy contract as an interface, and then you're having bunch of different smart contracts as a logic contract. Then upgrading system or upgrading a smart contract, let's say upgrading a DApp, means we swap out one of these logic contracts for another. So it's like, okay, till now I was like the logic contracts was contract A sitting at this address. From now on, we would use contract B as an upgraded version sitting at another address. It's a separated one, and then contract A will still remain on the chain, but it's abandoned because no one would call it from the proxy contract. And then this is the process. So this, but for the end users, it's like they're having only interaction with the proxy contract. So they just call the proxy contract at the same address. Everything is the same. Seamlessly, we change the logic of the contract. And this is the only technical reason that we can do is the delegate call in Ethereum-based smart contracts that we can use.
All right. So does it mean that you can, when you're building your upgradable contract, can you communicate between like Ethereum and Optimism, or Ethereum and like a layer 2 contract,
So,
or do you have to be everything in the same ecosystem?
what we mean by upgradable contracts, we mean in the same blockchain, in the same ecosystem, because the things you are talking is interoperability. So it's something bridging between two layers of the same blockchain system or different blockchains. So it's a separate concept. But upgradability takes place in the same blockchain.
Got it.
So having your upgrade your logic from logic A to logic B. And so these delegate calls, I want to talk about them because these delegate calls are the key technical point in this upgradability. When you're calling, when I'm talking about delegate call takes place on the proxy contract. So there's an interface contract or proxy contract. Users are calling the functions in this one. And then these proxy contracts use delegate call to call another contract. But this is different to normal calls. This is like they are executing the logic of that target contract in the context of proxy contract. So that's why we call them delegate call. It's like they are having their state variables there, but the logic is driven by the logic contract, by the other contract. And this is the key point for all of these proxy, because we are having different development and standards for this proxy pattern, but this is the key, delegate calls.
Okay, cool. So when you're developing your proxy contracts, and say for example you create like, I don't know, ABC, right? This and proxy contracts. So then when you say ABC contracts, does all three of them becomes proxy contract, or as Charlie mentioned, does B and C are the proxy contracts where A is the one that the interface which stays constant?
In a very simple case, we are only having one interface, one proxy contract, and there are some logic contracts. So we are having A contracts as a proxy contracts, which route all of the calls to different logic contracts, B, C, or whatever other contract, other logic contract. So Normally this is like this, but on top of this proxy contract also we can have different contracts. So we can have other interface contracts or different types of them.
Yes.
But let's simple with only one proxy contract and different
Got it.
versions of logic contract. Yeah.
Yes.
So
Okay.
yeah.
Cool.
Any question?
Mohammed, how does the gas behave? Splitting those that from that one interface contract into five proxy contracts behind it. Do you end up saving on gas through that process by breaking it down smaller? And also, I guess with that you'd be able to deliver more advanced, bigger contracts because you're breaking it down under that limit size as well. Is that correct?
Yeah, it's correct. About diamond contract, yeah, we can say because diamonds are getting different functions from different smart contracts. But other patterns like transparent proxy pattern or UUPS, universal upgradable proxy, these things are using only one smart contract as a logic contract. So we're saying that, okay, logic, for example, in transparent proxy contract, we're having like this. We're having a one proxy contract. And then inside this proxy contract, there is some admin functions which says that, okay, we now set the address of the logic contract. But this logic contract is only one contract, okay? So you are saying contract A is our logic contract for these part of stuff. So for example, so for some functionalities, you know that definitely only the whole, A part would be executed. So then all the calls only would be routed to this one, and then through the callback functions, we get the results. And then in the transparent proxy, we are having some admins who are coming here using the native functions of this proxy contract to set the logic contract. What normal does, always interacting with logic contracts. And it has some problems. It may cause some problems because we are having some function selectors in each smart contract. In normal contract also, when you are sending a transaction to a blockchain, first you are sending the address of the contract, and then you want to interact with, and then the signature, the function signature, or the function selector, which is a 4-byte. It's a hash of the name of the function and the inputs, outputs, the signature of the function. In one smart contract, EVM guarantees that there is no clash between these function selectors code, these 4 bytes. But in different contracts, there may be a clash. So because different contracts are sitting on different addresses, and in this transparent proxy pattern, you may end up clashing between native functions of the proxy contract and the functions in logic contract. So, and it ends up with a random, output, because the proxy contract doesn't know whether it should go to the native function contract or it should go to the logic smart contract and call that function there, which we call the function selector clash. This is the problem we are having in the transparent proxy pattern. It has been somehow resolved by, for example, if you're using OpenZeppelin's one, they're having a different administrative contract, which is separated from proxy contract, and then which is taking care of the the logic contract address, and then there's no clash between them because admins only contact with the administrator smart contract, users only going through proxy contract. So
makes sense. Okay, so can you in a proxy contract, so you just mentioned, I was going to ask the question, but I think you went there a little bit, so I'll ask a question anyway so that we can sort of dive into that side. So in a proxy contract, can you make it so that some contracts can be executed, like it's role based. Some smart, some proxy contract can be some roles and other contracts can be other roles. Can that be configured into the proxy contracts as well, like
So
role based proxy contracts?
yes, definitely you can have role-based proxy contracts. For example, in this transparent proxy, when you are contacting the interface or proxy contract, based on the address you're having, it makes a decision whether you are an admin or
Mm-hmm.
normal. If you're a normal user, you would be routed to the logic contract. If you're an
Yeah.
admin, you can have access to the native functions of that proxy contract.
Yeah.
So it's normal users won't have access to these to these native functions of proxy contract.
Okay.
All the accounts would be routed to the logic contract. Yeah.
Yeah. All right. So where I see, I don't know, I've kind of, when I look at proxy contracts, for me, it's a little bit above the database, going through a database, because it's like, what, it's somewhat decentralized, somewhat blockchainish. But when I look at the Web3, like pure blockchainish, it's not there. It's not the purest version of it. It's almost like centralized, but half, not, I don't even know the half or whatever, but it's a percentage decentralized, another percentage centralized, right? So yeah, you want to say something?
Yeah, it's like centralized on a decentralized network.
Yeah, centralized in a
It
decentralized
can
network.
be. It's more. I look at it more of it's commercial based, like
Commercial, yeah.
like a business, a Web2 business coming
Yep.
into Web3. Maybe there's reasons they want to change things in the
Mhm.
future, cut down rewards. Maybe they've publicized that.
Yeah.
That's what they would go with. But
Yeah.
in saying that, off topic for a little bit,
Yep.
is PayPal use like version 0.4 Solidity contract
What?
for their stablecoin.
No.
Yeah. It's like they copied an old Tether contract from back in the day and put PY
Unless they've been working on it for that long.
USD on there. But yeah, not to digress so much. We can get into that later. But I just found that was
Yeah, we
funny.
should see whether we can do a bit of a security audit on that.
Hey, let's do it.
Let's do a security audit on the PayPal. Yeah, exactly.
Yeah,
Why
I
not?
wonder if it's acceptable to re-introduce
Yeah.
text, Mohammed.
That's it. Hey, but when you're again, like, just talking about in this subject. So when you're doing that, launching that, deploying that contract, wouldn't you get notified saying, okay, the version is too old? Or, I mean, the SDKs nowadays, they do prompt, right, saying that this is an old version, or don't they? Unless the developers like, oh yeah, yes. Oh man, oops, too late. I said yes to everything. I agree. Yes.
Yeah.
So, yes. So, about so with this centralized and decentralized, right? It's like half, and as you said, this could work in an enterprise level, because it could be
Yeah.
say for a
Well, you put trust in Nike.
like a
But
membership.
they're going to deliver your shoes.
Yeah. I mean, like, it could be into a point like where the trusted party still got somewhat access to some
A game.
Yeah.
It needs to update certain things for certain reasons. It makes sense in the game.
So that can be like, so if you think about the assets and a marketplace contract, so we can say like the marketplace contract can be the proxy contract, where the NFT can be the 721 example.
Yes, but I still prefer to have a separate proxy contract and then separate facet, as I will explain it, for the market contract as well, because you may need to change the logic of your marketplace contract as well.
Yes.
So, but regarding the centralization issue you raised, there are some countermeasures you can take. So, in terms of when and who and what could be upgraded, actually, there are different countermeasures. Some popular ways is like having multi-sig contracts instead of only one admin and one, so which needs that several accounts to agree on some upgradability, and then only you can deploy the upgradability or migrate to a new version. Or the other one would be time locks, so which allows users to leave the platform before the execution time. So whenever you decide to migrate from logic A to logic B, you should set some variable on the smart contract. You should announce it on the smart contract. And then all the users are having like 48 hours or so, I don't know, whatever time you've agreed upon, uh, to leave the platform or to exchange their tokens. So there could be different strategies to minimize these centralizations, threats in upgradable, let's say, architecture, or even voting system. You can have a voting system to say that, okay, even if it needs any upgradability, needs a certain percentage of users to agree on it, to vote for it, and then only we would go and upgrade the logic. So this is when and who problem actually, and also what it is. So in the community, it could be discussed, and then people can vote for it. That what should change, when should change.
Yeah. Okay. So, for example, now, and how I see, how I understand proxy contract or upgradable contract is like this. So now, if I go and sign my wallet to a smart contract to interact with a smart contract, as we do now, if anyone, the next version of that of that platform comes, they release, I had to sign with the new smart contract and unsign or disconnect from the previous smart contract, right? Because if they found some sort of a security issue with the previous smart contract, I had to unhook from that one and then sign with the new smart contract, right? In a proxy contract, I don't have to sign anything, right? Because it get upgraded behind the scene, isn't it? So that's a benefit for the end user, so that they don't have to re-sign. They sign once and they move forward, and it allows the developers to upgrade and fix the security issues.
If in-house found a bug-free bug bounty, they can quickly, quietly go update
Update that,
without
them hand to, yes,
because
yeah, before they get drained.
Yeah. Well, having to tell the whole community, hey, those tokens now you got to bridge over.
You have to bridge
We're
over to the
going to
new.
airdrop you these new ones, and you're going to have to reconnect.
Yes.
And the whole hassle.
Yeah, and that's the biggest benefit in that stuff. And then same time, you had to balance, bit of a balance act with the community's trust factor, because even though it's a trustless system, I would say community is still trusting the smart contract. Really, that's what they're trusting, isn't it? Trustless system. So and that's what it is. So alrighty. So with the now proxy contracts or the diamond contracts, why you call it diamond contracts? Is it because like most of them are based on diamond contract pattern and not on the, is it UUIPS or something, I think, or UFO? Is it called UFO?
No, it's
aliens.
Yeah, UUPS is also another type of architecture for proxy pattern. Actually, the Universal Upgradable Proxy, EIP 1822, I think, it is so it's also somehow the same to the pattern. It's proxy pattern. We're having interface proxy smart contract, and we're having a logic contract. It's still one logic contract is there. But the point is that we don't have a clash problem here in UUPS. Why? Because to upgrade the smart contract, to upgrade the logic of the whole architecture, you don't need to go to the proxy contract and set it. The admin should go to the current logic contract, and then from there, this current logic contract actually inherited from proxyable contracts. It means that it would be extends some functions of a proxyable contracts.
Yeah.
So there are some admin functions available on logic contract. You go to current logic contract as an admin, definitely there should be access control there. And then you change from the current logic contract, you change
Mm-hmm.
the address of the next logic contract. And this way there is no chance of clash, because
Yeah.
EVM by default prevents you deploying a contract which has which there is function signature clash between these functions.
Yes.
So for one specific contract, definitely it is guaranteed after deployment that there is no clash between the function selectors. So function
Mm-hmm.
signatures are unique for this one smart contract. And because the upgradability functions and normal functions, I mean user functions, normal
Yeah.
logic functions, are at the same contract, are deployed with the same contract. There's no chance of clashing between them. But there is another problem there, that it could be viewed as a problem or as a benefit even. It is like, so if you set a new smart contract which is not proxyable, you know, then it would be immutable. So on logic A,
Of course.
on smart contract logic A, we are
Yeah.
having it like deployed. The first time deployed and says that, okay, admin can come here, change the logic to any other, change the address of the logic contract. If you change it to contract B and then contract B is not upgradable, then everything
Yeah.
would be locked to contract B. So this is a important point there. From some point is negative, because you may end up locking in some specific case that would be, in favor of admins, or I don't
Of
know,
course.
maybe by fault you go to and lock the
Yeah.
system in one logic. And but it also could be used as a benefit when we can say that, okay, after a specific period of time, we would make, so we are having some initial phase on
Yeah.
logic A, blah blah blah. Then after that time, we would be immutable, and that's
Yes.
guaranteed. Okay? So, but
Yeah.
you can't have this feature on transparent proxy. When you're setting the logic contract on the proxy smart contract, you
Yeah.
cannot have this locking
Okay.
uh, feature. Yep.
Cool. Alrighty. So when we talk about proxies, what is one of the latest? What are the changes happen? Is it like the proxies? Obviously, we spoke about how the NFTs moved, right, from different ERCs, and then next to the next to the next, right? What is that journey for proxy contracts? Was there
Yeah.
maybe a few different standards, or is it something that we call proxy contract, like for the final one, or what does that look like, and where are we going next?
Yeah. Uh, so there are different, minor proposals there with different, development or standards based on proxy contracts. But in general, we can say that we've seen a journey started from transparent proxy contracts, which uses a proxy contract to control the address of the logic contract, then coming to UUPS, which uses a logic contract to to upgrade the logic contract. And then at the end, the latest one would be Diamond, because Diamond is completely different compared to these two, more complex and different.
Yeah.
And this is so in most of the cases, if it's a simple task, we don't want to get involved with the Diamond one. So if it's a
Got it.
simple smart contract for a simple, straightforward business, we don't want to have these, diamonds, because I'll go through these diamond for a couple of minutes. That why they are more complex compared to these
Yep.
transparent and UUPS. So even Open Zeppelins and other companies are providing some, standards for UUPS, and libraries that you can use, these packages that you can make sure that there's no security problems in them, and then import these things, make your smart contract upgradable, and go on chain. So these are the things that most of the businesses would take when they want to be upgradable, because this is a simple one contract, one logic contract there. Then there's no need to make it complex. But
Yeah.
when you want the whole ecosystem to be dynamic and to be evolving, like when you're dealing with an NFT marketplace, you may have different types of tokens. You want to need introduce you may need to introduce upgraded tokens
Yeah.
with upgraded logics for your NFTs, or upgraded logics for your marketplace contract. All of these things could be changed, and it's
Hmm.
an huge interaction between these. You may have renting contracts. You want your renting actually standard also to be added there or removed. So this is a heterogeneous kind of architecture in the DApp. So you're dealing with different types of logics. Diamond actually is based on this idea of facets. So it's like this. So you're having a diamond contract as your proxy contract and the main contract, and you can have state variables of this contract set somewhere else actually, and make it safe. There is no problem with them.
Hmm.
Then you would have different, for each single function you can have a separate facet, and that's what they call it facet, because it's like a facet of a diamond. You
Yeah.
can cut it and make a new facet. So these facets are the keys in the diamond protocol. They are separate, independent, standalone contracts. So when you want to use these facets, you should go there and deploy them, and they're having their addresses and everything. Then after that, you can use these smart contracts partially in your system.
Hmm.
Like you are having a cut diamond smart contract. Exactly, it's like the diamond industry, traditional diamond creation. But yeah, if you want to add a new feature to your diamond contract, you should first cut it. And the cut diamond contract is introducing, adding, or removing, or replacing different facets
Yeah.
into your diamond contract. And it gives you this huge opportunity that you're not buying it to one logic contract. You can have as many number of the uh, as many as you want, the facets. So
Hmm.
facets are theoretically unlimited. Okay,
I mean, that
and then
that creates like, for example, I think that's going to create a nightmare when it comes to a nightmare, not nightmare, but maybe the job little bit more bigger for the smart contract audits team, right?
exactly.
Yes, and I was going to say, you Web2 developers think it's hard taking someone's code after 3 years coming to start. You know, the
Yeah.
memes of jumping into someone's
Yes. Yes.
code that was built 20 years ago. Imagine jumping into a diamond contract trying to fix that
I
in
mean, that's
like
it,
20
right?
years in the future.
That's just crazy. Like, and I think when it comes to coding, I always say is right. Um, when you're, when you're writing the code, there's two people knows about the code, right? That's you, who's a coder, and God, right? Once you finish coding, after 1 week, only one person know the code, and that's God.
Yeah.
I mean, you know, that's what it is. Like, when you look back the code, and it's like, oh my god, I can't believe I wrote that piece of code.
Now you're just calling
Um,
Muhammad God, because I know he knows the code a week later.
maybe 2 months, maybe 2 months later,
Okay, 2
right?
months. I
Let's do
haven't
two
seen
months,
that
yeah.
one yet.
So,
But yeah, interesting.
yes,
The smart contract auditing.
yeah. So
Muhammad,
how
on
do
a
you
diamond.
tackle that when it comes to auditing smart contracts on a proxy? Obviously, or it's like I mean, like it's like doing security audit, like pen testing on any on any code, right? Any piece of code. But does it differ, uh, you know, when it comes to proxy contracts?
Yeah, actually, it is harder, really harder when it comes to diamond contracts. It for transparent ones and UPS ones, still you are dealing with one logic contract, which
Yeah.
makes it easier for you. You just need to, be checking how delegate calls are working uh, are functioning, and we may end up in calling and endless calls to the logic contract or these kind of stuff. But when it comes to the facets, they're also sharing their variables. They're sharing memories, and there could be a huge amount of security holes there. So it needs a proper auditing, because you may use part of a function, well, you may use one part of a smart contract as a facet in your diamond, and then part of another smart contract as second facet in your diamond, and then you're having a storage contract, which which should be actually controlled by these two logics, and they're having their own logics and problems, each of these facets. So because and it's a dynamic process. So whenever you
Yes.
want to introduce a facet, you should again check all the current facets and make sure that it meets the requirements, the security requirements, and then
Mm.
you can add it, or sometimes you need to remove a specific facet definitely before adding this new one. So it's a dynamic process. Whenever you want to
Yes.
upgrade, definitely a new kind of auditing is needed,
Yeah.
especially on employment contracts. On
Yeah.
other patterns, you can have one shot of auditing, but this one is really,
It's a
really
little bit
complex.
cumbersome, right? Because I
Yeah,
remember when we did the couple of those smart contract audits in the like the proxy smart diamond contracts, and it is it's a little bit more involved than the rest of the other contracts because of the complexities,
Mm-hmm. Mm-hmm.
how they interact. So alrighty, so I guess we are getting closer to the end of the podcast. Before we end, did we miss out anything from your list that you really, really, really want to talk to us about, Mohammed? I'm pretty sure that he got about 10 different things, right? He's like, oh my god, you guys just talking about stuff. You didn't let me talk
I
about
didn't
you.
even
You just
get to the meat
the
yet.
meat yet. You know what I mean? And that's what happened last time as well. Remember, he's like, Mohammed's like, oh guys, I didn't get enough time. You know?
so actually, we can have series of episodes regarding upgradability, because we just touched the surface in general. Okay, in general terms, what are different types of proxy pattern development and standards, and we've spoken briefly about each of them. But one important thing about a diamond that I want to mention is that this is the so you're dealing with loop diamond, cut diamond, and the diamond contract and the facets. So whenever you need to add it gives you modularity, because any function, any part of your smart contract you want to fix, you can have a separate facet and then use that facet. How this works is like this: we are having some sort of mapping, or let's say a struct, if any blockchain developer is watching us. So which is a selector to facets. So it says, if you want to do this functionality, byte 4 of this, which ID of this function, go to this address. If you do this one, go to this address. And this is the cut diamond contract, which controls these things. Okay, so functionality number 1 was actually the functionality number 1 is by logic A, and then you go to the cut diamond contract and say that now this functionality should go to this address. So each single functionality of the whole ecosystem could go to different addresses, and we save these. So this is a kind of the difference between Diamond and the others.
Okay.
And the final point from my side is that
A problem. Did you say problem or feature? Problem.
the problem.
Opportunity.
Yeah. Problems are always opportunities. Yeah. There are two different, sides when it comes to the upgradable. First, the team that they're gonna use these upgradable contracts in their dApps. First of all, you should take care of it. It is not a normal, simple job to do. It needs experienced developers with enough knowledge, and then enough, auditing process definitely before going to the market, especially when you're dealing with Diamond contracts. For any reason you decide to go for Diamond, there are different developments for Diamond in terms of gas consumption, they are different, and then there are different features there. But you should take it with care. This one, it is very complex job compared to the other stuff on blockchain. And for the users, I should say that any kind of dApp you want to join, or you want to put your money in, definitely you should have a blockchain, a discussion with blockchain consultant or anyone, or if you have the knowledge, go through, check the smart contracts. That's a general, advice. But when it comes to upgradable contracts, this is also, and there are other factors you should consider as well. So how trusted these people are, how their team, how do you know them? And this is not like, because if there's no governance countermeasures there, it may end up in centralization. If there's any technical problem there, it may end up, blowing up the whole system, not like a simple smart contract. So definitely you need to discuss with blockchain consultants and having some sort of discussion, thinking before joining these, and having trust on the team, especially before joining a dApp which is going to use upgradable smart contracts. Yeah.
Okay. Cool. All right. Awesome. My brain is like fried. I'm still stuck in the UFO. Aliens. But I know that Mohammed and Nathan had an awesome time. I can see Nathan behind the scene, like Nathan, like, oh my god, this is like, he is like hooked to the to the screen, right? Nathan, like, okay, I think I got this.
He's like, diamonds?
Yeah, diamonds?
Diamonds?
Yeah.
Awesome.
Yeah, exactly. He's thinking of his next diamond earring, Mr. Bling. Mohammed, thank you so much for that, for your insight.
Yeah.
I think we can, I know that you can, not we, I think you can definitely talk a lot more for weeks to come on this subject. But unfortunately, we just only got 1 hour. But I think definitely we'll catch up a little bit more about other contract standards as well, more specific standards, and discuss about how we can add those benefits and, what are the pros and the cons on those ones as well. So on that note, guys, what about you, Charlie? You got anything to say? Before we...
No, it was awesome. Awesome to have Mohammed back on and going through some contracts. And I hope everyone learned some valuable knowledge today.
100%. Exactly. On that note, guys, thank you everyone for joining us, and have an awesome weekend. And we'll see you next week. Thank you so much. See you later.
See you.
Thank you, Mohammed.
Thank you so much. See you.
Thanks for tuning in. We'll see you next week. Same time, same place.
Subscribe.